to be that time of year. Getting a little chilly. Gotta wear the heavier jackets. Extra sweaters underneath everything, yeah. Anyways, some thoughts on the universe, the nature of the universe, the antiquity of the universe, how the universe works. The universe has been measured at about 13.5 to 14.5 billion years old. This is not a guess. This is a measured age based on the known and established speed of light and the rate of recession. We've established by actual measurement that the universe is 13.5 billion years old, thereabouts. This is established scientific fact, testable, verifiable. The Earth within the universe is about 4.5 billion years old. So a little under a third the age of the universe. Yeah, about 1/3 the age. And the Earth is made of leftovers from the formation of the Sun, which is a G-class star and is either third or fourth generation. The first generation stars were massive, supermassive, and they are the forges in which all the light and medium weight elements were created through stellar fusion and through supernovae when the stars exploded. Then came the second generation of stars made up of the remains of the first generation stars. And these stars were where we got the heavier elements, iron, gold, uranium, stuff like that. The Sun is a third or fourth generation star, made up of the remnants of older stars that are made up from, again, older stars. And the Earth is made up from the debris left over from the formation of the Sun, the remains of a process. And the Earth has all these heavier elements because we acquired them from older sources, older stars that went supernova, and in doing so forged the heaviest elements. So no, the Earth is not the oldest thing in the universe. It's not even close. The Sun is not the oldest thing in the universe. And neither the Earth nor the Sun are at the center of the universe. Both are far removed from the center of the universe. Very far. Very, very far. Absolutely. Further than social distancing, yeah, much further. Yeah. Further than a religious fundamentalist from a good idea. Yeah, I had to throw that in. It's true, though. And when the Earth was formed, it was clumped together, built by accretion, adding more and more bits of debris until it became about the size it is now. And then it collided with another infant planet, which we have called Theia. And this collision merged the two planets, the two protoplanets together. And much of the debris left over, the crustal material from both of these planets, became incorporated into an object that we call the Moon, which has since been a great stabilizing influence on the Earth and may have made it possible for life to exist. This impact also completely melted the Earth, causing all the heavier elements to sink to the center, which gave us a core of heavy nickel iron. And thanks to the influence of the Moon, this core began rotating at a different rate than the rest of the Earth, thus creating a dynamo effect, which gave us a magnetic field, which in turn protected us from solar radiation, which again made life possible. Most of our water comes from asteroids and comets bombarding the Earth. Water is a very common compound. It's not an element, it's a compound. Hydrogen and oxygen, which both bond together very, very readily, especially when given pressure and heat. One need only look at modern hydrogen fuel cells, which give off water as their waste product. Hydrogen, add oxygen and pressure and heat, boom, you've got energy, and the exhaust product is water. Now, if we could find a way to make these efficient, it would be great. Solve most of our energy needs. Yeah. That's going to be a little while, though. But I digress. Water is a common compound in the universe, and the Earth doesn't even have most of the water in the universe, or even most of the water in the solar system. Most of the water in the solar system is tied up in the atmosphere of Jupiter. And even Jupiter's moons, some of them have more water than the Earth has. Yeah, fun thing to think about. There's probably more water floating around in the asteroid belt than there is on planet Earth. That's where our water came from. And of course, water was necessary for life. So we have two things: the moon stabilizing the Earth, the moon helping to propel the dynamo of the Earth's deep magnetic core, generating the magnetic field, and the presence of huge amounts of water. But not all the water, just a lot of water. On a planet that had an atmosphere originally mostly carbon dioxide. But with the presence of water, we also started to get weathering, and with the presence of a rotating dynamo, we had magmatic currents, which created plate tectonics, which created subduction and the conversion of rock from purely igneous to sedimentary and also to metamorphic. And this led to the creation of other gases, including nitrogen and methane, which became very prevalent in the Earth's atmosphere, thus creating the perfect environment for life. Oxygen is actually hazardous to life initially, which is why when oxygen first became prevalent as a waste product from plants, it caused an extinction event. Huge, devastating event, the oxygen crisis. And the oxygen crisis also gave us most of the iron deposits on the Earth's surface. Banded iron formations caused by the introduction of large amounts of oxygen, causing the dissolved iron in the world's oceans to rust out and percolate to the bottom, forming deep, deep layers. It's a whole lot of iron. Yeah. And all this took place before the first human ever existed. Indeed, before the first real animal even existed. When all life was single cells, and there was not yet something you could look at and say, this is definitely an animal. Instead, we had protozoa and primitive eukarya, which are, plants, animals, and fungi are all eukarya. What we had is simply eukarya, undifferentiated eukarya. And these undifferentiated eukarya were the first of our ancestors to exist. And that happened about probably 2.5 billion years ago. The earliest eukaryotic cells. Hey, could have been worse. And those primitive eukarya included protoplants which gave rise to the oxygen crisis, which may have been an important step in the evolution of the first animals. And yes, I acknowledge tentativeness, because this is what honest scientists do. We are tentative. Science is always tentative, because there may always be another discovery that proves that we were mistaken in what we know today. So, yeah, the first life was not human. It wasn't even animal. The first animals were not human. They were derived from plants. And it took a long time before we got multicellularity down as well. Absolutely. You and I are the end product of a very, very, very long chain of evolution. We're the success story, and that's something to be proud of. We are the descendants of the survivors of multiple extinction events, multiple calamities, multiple great changes. And we've proven that we are adaptable. Yeah. That's a good thing. That is a good thing. And that is the triumph of evolution, that we, having adapted and overcome, have continued to the present day. Something to be proud of, don't you think? Now, doesn't evolution sound so much better when you think about it that way?